Okay. Can I start? You want? Yeah. Okay. All right. So. Yeah. Good. Suboor, can you? Is that okay, everyone?
Can you stand a bit further away, maybe?
Yeah. Here.
A bit further. There you go.
Can I be seen in that? Yeah. Okay. Cool. Yeah. Okay. Cool. All right. So we're going to debate evolution and whether humans and chimps share a common ancestor. The reason this is a particularly important aspect of evolution because it's the aspect that Suboor has said is the thing that Islam is clear about didn't happen, and I think the evidence is clear that it did happen. So I'll just present a little bit of evidence. There's lots of it. We've got evidence from genetics, from paleontology, from archaeology, from biogeography, many fields of study. I'll just start with like one paper that's very important. It's this paper here. It was in Nature. It's the sequence of the chimpanzee genome, and it's done by the Chimpanzee Consortium, Genome Sequencing Consortium, and many of the world's leading genomic institutes signed off on this paper, and this is what they said. They said more than a century ago, Darwin and Huxley posited that humans share recent common ancestors with the African great apes. Modern molecular studies have spectacularly confirmed this prediction. So, you know, they don't usually have in science journals like quite such strong language. But the reason it's strong is because we really do have spectacular evidence for it. So let me give you just a couple of examples. So there are genes that get duplicated, and when they get duplicated, they can malfunction. They can lose their original function, shall we say. And these are called pseudogenes. And if you look at the chimp genome, there's many pseudogenes there. Just take one example. There's a pseudogene called nanog, and if you look at how many pseudogene copies they have, the chimpanzee genome has 10 pseudogenes of nanog. So if you like, these are like shared errors. So imagine someone hands you some homework, and then the teacher goes, hang on, I know that guy's older brother, and he handed in a very similar piece of homework 2 years ago. How would you know if he copied it? Well, if they had the same typos, you know, that would be very good evidence that it's been copied, or they'd have the same source. And this is what we're talking about here. They've got the same errors in the same location. And that's very hard to explain if evolution is not true, but if evolution is true, perfectly explained. Now, if you look, these are the nanog pseudogenes.
Okay, one sec.
Let me just finish this point, okay, and then come back, okay? So you can see that they're at the same locations, same errors, but there's one nanog pseudogene that humans have that chimps don't have. Okay, that is nanog P8, not present in the chimpanzee genome. Now, if evolution is true, there's one way to explain that, and that is nanog P8 must have become a pseudogene after we split with chimps. So now what we can do is use molecular clock technology, and we can see if that's true. If evolution is true, that must be true. So they looked for that, and this is what they said. Human nanog P gene is located on human chromosome 15. It is the most recent of the nanog process pseudogenes, exactly as evolution predicts. But evolution can make a more precise prediction, because these pseudogenes, some of them are more than 100 million years old. They could be any age, really. But if evolution is true, nanog P8 must be younger than the human-chimp split, and that's estimated to be about 6 million years ago. So we use molecular clock technology, and we see how old it is. If evolution is true, it must not be older than 6 million years. And here's the estimate. Here's the paper. It says it's between 0.9 and 2.5 million years old, just as evolution predicts. But we can go even further than that, because of that age. Now we know that age, we can say this: they've now sequenced the Neanderthal genome. And we can say, well, once we've got that genome sequence, when did Neanderthals and humans split from each other? And that answer is between 400 and 700,000 years ago. So if that's true, then it must be the case that nano-PA is in the Neanderthal genome. And we don't know this a priori. It might be true, it might not be true, but if evolution is true, if humans and chimps share a common ancestor, we should find nano-PA in the Neanderthal genome. And here's the paper. As you can see, nano-PA is present in the Neanderthal genome. So that's one piece of evidence. We can go, I've got loads more, but I don't know if you want to respond to that.
So, the position which I'm defending today is that human-chimp ancestry, it's been projected to the public like this is a fact, like this is true. And in the way that Phil just explained right now, that they have spectacular evidence that it's actually true. Now the case I'm going to be making is quite simple. It is that human-chimp ancestry is not true literally. It is not a fact in the absolute sense, in the sense that it doesn't change and that it cannot be corrected due to future information. It is a scientific hypothesis which is based on a probabilistic framework which has assumptions, and there can be core disputes about it. Now, let's just go back to your first slide, because you said a lot of things. I want to deal with each one at a time, right? So let's go back to your first slide.
Sure.
And the way we're going to do this is that once he makes a point, then I'm going to address those points, and then he can carry on, make new points.
Okay,
go back.
Fine, yeah. There you go.
First slide. First slide.
Sorry, yeah.
First slide. Your first slide. Your first slide.
Oh, okay.
Right.
This, yeah.
So just give me that for a second.
Sure.
So the first thing that Phil did, and I think this is very important, is that he basically said this is the evidence for human-chimp ancestry. He spoke about genetics, paleontology, archaeology, biogeography, right? Now these are different fields. Now the first point to make is any scientific conclusion in any scientific field can be revised based upon new information. So for example, you were mentioning about pseudogenes. Another piece of evidence which was used apart from pseudogenes was junk DNA. Junk DNA was used as evidence that we have natural selection responsible for leaving behind all this extra junk. Natural selection, the way it works is it's a very wasteful process. It's a process which punishes for, it rewards for a slight incremental advantage, and it punishes for something which is wasteful. Now, when it actually comes to junk DNA, we later on discovered that that wasn't actually junk. Much of it was actually functional. So if you want to point at something in genetics, whether it's pseudogenes or junk DNA or something else, the same principle applies. The problem of induction is a reason why we can't say that it's absolutely true. Now, about these particular fields.
Thank you.
So, whether it's genetics, biochemistry, linguistics, biogeography, anatomy, or the fossil record, each of these, when it comes to human-chimp ancestry, this is still based upon homology. Now, homology is the assumption that similarities, whether at genetic or anatomical or biochemical level, are due to common ancestry. That is an assumption. Now, for someone to say that it is a fact, what they're basically doing is they're assuming that there is an argument to be made. Now, the argument which is actually put forward goes like this, and I want Phil to tell me whether he agrees with this argument. Similarities are due to common descent. Hey, look, similarities exist. Therefore, we have evidence of human-chimp ancestry, or therefore we have evidence of homology being true. Do you agree with this argument?
No, of course not.
You don't?
No one in evolutionary biology thinks that, right?
Okay.
That's just ridiculous.
So you don't believe it's a fact then?
No, I believe human-chimp common ancestry is a fact, but it's not a fact just because humans and chimps are similar. No one is saying...
That's fine.
Right, no one is saying because they're similar, therefore they have a common ancestor.
Sure, so the
In fact, if you listen to what I said, we're actually looking at the dissimilarities as well as the similarities.
Sure.
There are subtle patterns between similarities and dissimilarities. So if you take nano-PA is not in the chimp genome, right? We don't, right? So we're not just talking about similarities. We're talking about the dissimilarities as well. But there are consequences of the similarities and the dissimilarities. The way you assess this is the theory makes a number of precise predictions and then using very parsimonious assumptions.
Yeah.
Then, again and again, if you keep finding that the predictions are found by the evidence, then you say that theory is true. Okay. Now,
wait.
Hang on. Let me just. I want to come to what you said. Hang on. I want to address what you said.
Sure. But I asked a particular question, which is, I summarized what you said there in an argument. I want you to tell me whether this argument's correct or it's incorrect.
Okay. If I understood what you